How does a hybrid car work? Who invented the first hybrid? And what are the different types of hybrid technologies? Stay tuned, because I'll show you today. The word hybrid generally refers to a cross, combo, or blend of two things. So it makes sense that a hybrid car would have two different engines. Sounds simple, right? A hybrid car generally has two different engines, an electric motor and an internal combustion engine. In a hybrid car, the driver can't manually choose which engine to use. Instead, the car's internal computer decides which engine to prioritize, depending on the car's RPM and road conditions. And here's why that's smart. The electric motor is efficient in creating torque. The internal combustion engine is better at maintaining high speeds. Since each engine is more efficient at different speeds, you can see how working together helps a hybrid car use fuel more efficiently. For example, if you're in the city, stuck in a traffic jam, your hybrid car will use electricity because it's more economical. But let's say you eventually get out of gridlock and your car needs to pick up full speed. Well, then the car switches to the combustion engine. And if you need to accelerate quickly and often, the car can use both engines simultaneously. Smart, right? So how does a hybrid engine work? First, you have electric energy that's stored in the battery. This energy goes to the inverter in the form of direct current, or DC. The inverter is an energy converter. It converts direct current from the battery into alternating current for the electric motor. The inverter also distributes electrical load to different parts of the car. So now that your electric motor is running, the car can pretty much get up and go. The electric motor runs smoothly and makes very little noise. When the motor reaches its maximum speed, the internal combustion engine gets activated. This is the symbiosis of the two engines. In fact, the term hybrid car came from the term hybrid engine, or this interaction between these two engines. So why are many car manufacturers switching to hybrid technology? Well, it's mainly because of rising fuel costs and stricter regulations around toxic emissions, but also to increase driving ease. These factors may be more recent, but the history of the hybrid engine is actually quite old. In fact, it dates back to the late 1800s. In 1899, a 23-year-old Austrian engineer named Ferdinand Porsche, yes, the Porsche car man, created one of the first hybrids. It used an internal combustion engine, which spun a generator that provided power to electric motors located in the wheel hubs. On battery alone, the car could travel almost 40 miles. In 1901, the Lerner Porsche mixed hybrid became available to consumers. They sold 300 total units. The model turned out to be very practical, but the downside was that it was quite expensive to manufacture. So the average consumer couldn't afford it, and competitors were offering cheaper, more practical cars, like ones made by Henry Ford. That's why from 1901 onward, for several decades, classic combustion engine cars dominated the world. In the 1960s, the United States created an incentive bill to promote electric transportation. The bill passed, but interest in environmentally friendly cars remained only on paper. Not much was put into action for them. In the 1970s saw the oil crisis. This caused soaring oil prices and gasoline shortages, which finally pushed car makers to become more serious about alternative technologies. Three engineers at TRW Incorporated Power Systems, Dr. Baruch Berman, Dr. George Gelb, and Dr. Neil Richardson, devised the first working example of hybrid electric drives that we see today. Most of the engineering concepts incorporated into their systems are used in today's hybrids. An example of a complete hybrid car from that era was the GM 512 Hybrid. The car was powered by an electric motor that could accelerate the car to 10 miles an hour. At 10 miles an hour, the combustion engine kicked in, giving it a good boost that increased the speed to 13 miles an hour. If you needed to go faster, the electric motor would switch off and the car would use the petrol engine's power. Car's top speed was 35 miles an hour. Doesn't sound like a lot to me, but it was back then. Just 3 gallons of gas could take you 150 miles. Volkswagen also experimented with the Volkswagen Taxi Hybrid. It was a bus van that used a parallel hybrid configuration. Meanwhile, car makers like Mercedes, Benz, GM, and Toyota continued exploring hybrid technology without reaching mass production. It's 1979. An electrical engineer from Arkansas, David Arthurs, developed the regenerative braking system. It slowed down a moving car by converting its kinetic energy into a form that could be used immediately or stored until needed. Using his invention, he converted his Opel GT into a hybrid car, and his hybrid traveled as much as 75 miles per gallon. In 1997, Toyota debuted its hybrid Prius in the Japanese market. Soon after, in 1999, Honda introduced its model Insight Hybrid into the U.S. So let's talk technology. Hybrid cars can be categorized by their type of powertrain or how power is supplied to the drivetrain. There are three main types: parallel, series, and power split. Let's look at them closer. Parallel hybrids have an internal combustion engine and electric motor that are connected to the mechanical transmission. They can transmit power simultaneously to drive the wheels, usually through a conventional transmission. With this type of architecture, the internal combustion engine can also serve as a generator to recharge the battery. Parallel hybrids are more efficient than comparable non-hybrids, especially in stop-and-go conditions where the electric motor can contribute, and also with highway conditions. Parallel hybrids are usually more efficient at high speeds. Example of parallel systems include the Honda Insight, Civic Accord, and the Chevrolet Malibu. In a series hybrid, only the electric motor drives the drivetrain. The internal combustion engine tends to be smaller. Pretty much it works as a generator, and it powers the electric motor and recharges the batteries. On the flip side, a series hybrid car usually has a larger battery pack than a parallel hybrid. This is why series hybrids are usually more expensive. When the batteries get low, the combustion engine could generate power at optimum setting. That's why series hybrids are more efficient at lower speeds, which means it's great for people who do a lot of city driving. A third type of hybrid is called series parallel hybrid or power split hybrid. It has characteristics of both the series and the parallel setups, and therefore has benefits that are inherent in both systems. Overall, this type is more efficient. It's also more expensive than a pure parallel. You probably heard of full hybrid, mild hybrid, and plug-in hybrids. That's another way to categorize hybrid cars. In fact, as a consumer, you probably heard these terms more. Here's how you can think of them. A full hybrid car can run on just the internal combustion engine, or just on the electric motor, or a combination of both. The Toyota Prius is the most commonly known example. In a full hybrid, the battery gets recharged when you run the internal combustion engine. Full hybrids have a large, high-capacity battery pack, so they can run on battery only when needed. A mild hybrid car always relies on both the combustion engine and an electric motor. It can't run just one engine or the other because the electric motor doesn't have enough power to move the car on its own. Basically, a mild hybrid is a conventional car with an oversized starter motor. This means the engine can be turned off whenever the car is coasting, braking, or stopped, but then it can restart quickly when needed. Mild hybrids have smaller batteries and smaller motors than full hybrids, so they're cheaper than full hybrids. Then there's the plug-in hybrid car, or PHEV. Plug-in hybrids can run on electric mode only. You can fully recharge the batteries by connecting it to an external electric power source. Plug-in hybrids have a larger all-electric range than conventional gas-electric hybrids. Sometimes critics say that hybrids are less reliable than conventional cars, but this was proved wrong by ratings in the US and the EU countries, where hybrid vehicles are the car industry leaders in terms of reliability. What are some advantages of a hybrid car versus a standard combustion engine car? In a hybrid car, all systems work automatically on their own. Hybrids also use 25% less gasoline than the average conventional car. Most hybrids can be recharged with a kinetic energy recovery system called regenerative braking. Another benefit of hybrids is that they produce much lower levels of toxic emissions. Studies show that a hybrid car emits 90% less harmful gases compared to a conventional car. Since the internal combustion engine recharges the batteries, hybrids have a large power reserve, which give hybrids a huge advantage over fully electric cars. Unfortunately, maintaining and repairing a hybrid is more expensive, which can be a huge turnoff for many people. It's more expensive because the system is much more complex than a traditional car, so it requires very specific mechanics labor, high-tech parts, and very sophisticated electronic equipment, which are costly. It's virtually impossible for the average consumer to fix a hybrid car on their own in their own home garage. It's just not as easy as fixing a conventional car. The overall price tag for a hybrid usually costs several $1,000s more than diesel or gasoline models. Because the more economical the hybrid car, the higher higher capacity battery it needs, which bumps up the price. Some problems that can happen with hybrids include battery self-discharging, especially due to drastic temperature changes in winter. And while running the electric motor is economically friendly, making and disposing the batteries actually causes environmental pollution. It's a paradox of its own. Hybrids are definitely becoming a tough competition for combustion engine cars. Car manufacturers have been shifting to alternative engine technologies in modern times, and we can only expect it to evolve even more. So what's next? Only time will tell. If you like this episode, please like this video. Thank you.